Okay, so today we only had three problems that we're looking at. The first one actually comes from our notes. So, this first one, we already lined out all of these probabilities in our notes. So, if you didn't get that down, you might want to do that now so that you can understand where the 1 out of 16 comes from and the 4 out of 16 that just came from the lesson above. From there, it asks in part B, after you have the probabilities that we already found, to go ahead and graph them. You'll notice that I did this on a 10% scale. So like 10%, 20, 30, 40 scale. And these were the probabilities here. This is a nice symmetric curve, right? And you can see that in the probabilities. This is actually completely symmetric distribution. In part C, they're asking specifically, find the probability of x less than or equal to 3 and interpret this result. What that means here is having less than or equal to 3 heads. Well, that's 3, 2, 1, or 0. What you could do, and what I probably would do, I added them all up here so that you could see those 3, 2, 1, and 0. I added those all up, and that gave us a probability of about 94%. But the other way that you could do it is you could actually just take 1 minus this 6% probability. If it's 3 or less, then you could do 1 minus the probability of having 4, which would give us that same 94% just a little bit faster. Okay, so for number 2, you have a pair of dice. This one does take a little bit of time, and that's why I only gave you guys three problems tonight. In order to get the probability, so you're rolling two dice and they want to know what's the probability of getting the sum of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So in this one, you'll notice that I have these probabilities, but I want to show you where I got them from. I created this right here. You could roll a 1 and a 1, you'd get a 2. A 1 and a 2, you'd get a 3 as your sum. 1 and a 3, you'd get a 4, and so on and so forth. You can see I've made all these, like a 6 and a 1, 7, 6 and a 2, 8, all the way to a 6 and a 6, where you get a sum of 12. So what I did to get these probabilities is I actually found the probability of getting a 2 is 2 out of 36 different possibilities. The probability of getting a 3, well, there are two threes, so I took a 2 out of 36. The probability of a 4, 1, 2, 3 out of 36, then 4 out of 36. 7 is our most frequent. You'll see that here, it's 17%. The way I got that 17% is I took 1, 2, 3, 4, 5, 6 and divided that by 36. Okay. After that, it asks you to graph that distribution. So I only had to go up to 15%, 17, you'll see it goes a little above that. I could have put 20 up here, but that's my most frequent, which is a 7. Okay, so from there in C, it asks you to calculate the probability of getting a greater than or equal to 5, like a sum greater than 5, greater than 5. Well, actually greater than or equal to 5. So 5 is included. So that would be 5, 6, 7, 8, 9, 10, 11, and 12 added together, all those probabilities. What I did instead is I actually did, because that would be a lot to add up, I took 1, which is the whole thing, and took out 4, 3, and 2. I took out those probabilities instead because it ended up being a little bit easier to do. But either way, you're going to get 83% or 0.83. Okay, and in our last example, number 3, okay, last example of the day. In this one, it's giving you a table for the probabilities of non-word errors, and all you had to do here was calculate different events. So this first one says, write the event at least one non-word error in terms of X. So that's what it would mean here. Probability of X at least 1 is greater than or equal to 1. Greater than or equal to 1. And I added 1, 2, 3, and 4 non-word errors, and we would have a 90% chance. At least 1, you could also look at it. That's 1, 2, 3, and 4, so you can get rid of 0. So 1 minus 10% would also be 90%. In the next one, it says describe the event X less than or equal to 2 in words. Well, what that would mean is that's the probability of having no more than 2. Or you could say the probability of having less than 3. Less than 3 would be 2, 1, and 0. So that's what I did here. I calculated that 2, 1, and 0. It's 60%. And then it says, what's the probability of having X less than 2? That does make a difference here. In discrete, it will make a difference. It won't on continuous when you guys see that tomorrow. But right now it does make a difference because that's eliminating the 2. So now you're only looking at 1 and 0, which is a 30% chance. And that is all for homework tonight.